Is she asking for one to give to the repairman at our house? Or does she need it for our son's lacrosse bag? Maybe she is just going hiking, or needs the one that fits on her bicycle. Perhaps she is just socializing by the pool with some friends. To pick the right water bottle for her, I need to know her purpose. This rings even more true with data visualization than with water bottles. Before you pursue a data visualization, define its purpose. In this example, my purpose is to advocate for making product C, but with one caveat. I want to revisit the feasibility of making product D. Its potential profit is sufficiently higher than product C's that maybe a last burst of creativity will make it a feasible solution. If your purpose is not persuasion, you can get away with much less. This is my hastily made exploratory plot of the same data. Perfectly good for its exploratory purpose, despite being much uglier than the previous plot. As part of making any plot, you should work through the following 4 stages of data visualization. Stage 1. Purpose. What outcome are you hoping for by creating the plot? Do not discount this step. Heading in the wrong direction is a good way to waste time and effort. Stage 2 is content. Find and create the right data as needed. Just like finding the right water bottle, find the data aligned with your purpose. And often, the right data does not even exist. Be brave, though. Make and collect your own data if you need to. No, I'm not saying create fictitious data, but say you want to highlight the top 3 observations with a different color. Well, create a new column of data that flags those top 3 observations versus the others. Stage 3 is structure. I will rely on this Harry Potter movie clip to help you remember this stage.
When I call your name, you will come forth. I shall place the sorting hat on your head, and you will be sorted into your houses. Hermione Granger?
Oh no. Okay, relax. Mental, that one, I'm telling you.
Right then. Right. Okay. Gryffindor!
Just like the sorting hat creates a mapping from student to house, in the clip Hermione got mapped to Gryffindor, the structure step maps data to the right visual aesthetics. Stage 4 is formatting. Channel your inner artist for this last step. The goal here is to evoke the intended emotions from your audience. Be motivational, be artistic, and show your audience you're a pro. Spend time on this step when it's needed, but know that it can be a giant rabbit hole where hours slip away as you perfect your visualization. Let's journey together through the 4 stages and see how they get us from this exploratory viz to this final visualization. Since purpose should be set in the context of strategy, for learning purposes, I provide the purpose now. Imagine our company, Water Bottle Inc., wants to launch an additional product. 6 alternatives, A through F, have been proposed, prototyped, and market tested. Water Bottle Inc. is a profit-maximizing company, and the market tests indicate varying degrees of anticipated profit for each of the alternatives. Given current manufacturing capabilities, it turns out products D and F cannot be made at scale. Our purpose is to create a visualization for the marketing executive team that shows 2 key findings of our results. 1, of the currently feasible options, product C is the best. And 2, among all options, product D can earn even more profit. stage 2 content all the way through stage 4 formatting that resulted in this final visualization. In terms of content, let's assume we're given this initial data frame. This initial data frame has everything we need, but we have to do some mental work for it. We can see that alternative C is the best of the feasible solutions, but only after comparing it to the other options in the table. We can also see that alternative D has more profit potential than alternative C, but again, we have to do some mental work for it. Even when I do an exploratory plot, the information is there, but the insight isn't readily forthcoming. To have our key points made, we actually need data that represents these key features of the data. So we're going to create another column. The column will be used to flag both alternative C as the best feasible option, as well as showing the infeasibility of alternative D. Hold on, Adam. I see what you're doing here. You're going to create some data, and you're going to call that column category. But what's this case when function? I've never seen that. Oh, all right. Package. We use the library command to load the package into our R session and create a fake vector called x of numbers 1 to 10. You can see the sequence down below. We're going to now use an if-else statement built into base R that does an element-wise comparison between the vector x and the number 3. If the element in the vector x equals 3, we're going to write out the number 3, THREE, otherwise we'll just return the value of x. When we hit Control Enter, we get a 10-element vector with the 3 replaced by the text. You might also notice that the numbers are now in quotes. That means they were turned into characters instead of numbers. If underscore else is a function from dplyr, it forces the output when true, the word 3, and the output when false, the vector x, or the element from the vector x, to be of the same type. To overcome the error, we make the vector x the same type as the word 3 using the asCharacter function, and then we get an errorless execution of the function. Case when is just like dplyr's version of if-else, but you use it when you have multiple categories, not just true and false. The left-hand side of the tilde indicates a condition. When true, it returns the right-hand side value. So when the element of x is equal to 2, it returns the word 2. When the element of x is equal to 5, it returns the word 5, all capitalized. And if it gets to this third condition, which is just true, means if true, then return asCharacter of x. So that's the default condition. If none of the above conditions are true, it will return this last one. Now back to where we were creating data about categories so that we can include that data in our final visualization. Now we have the content we need. Structure. There are 3 columns in my data frame that I want conveyed to readers: alternative, value, and category. Without hesitation, I know my 2 most important mappings of graphical aesthetics to data are the mappings for the x and y axes. These potential arguments can handle unordered and ordinal data and data with small or large cardinality. They are simply the most powerful aesthetics we have. For us, that means alternatives A through F go on the x-axis, and value will be mapped to the y-axis. The last mapping to be done then is category. Category is sort of ordinal. Feasible is better than not feasible. Best alternative is better than not the best alternative. So I will map category to fill color, and then eventually tailor the colors to indicate the importance ordering among the categories. Lastly, I choose geom_col as it works well for comparing relative heights of the value column. We get a nice colorful plot, but the way color got mapped to category is not ordinal at all. So now let's move into stage 4, our last stage. We're going to take control of the finer details of our plot. The one that annoys me the most at this point is the color ordering. To get the unique categories of the plot, I pipe our plot dating frame to a select function where I simply select the category column, and then I use the distinct function to get unique values. They're printed out below. My goal now is to create a column of colors that map each of these 4 unique values to a color. To add a column of colors to these distinct categories, I will use the mutate command and call this other column color. I will then create a vector and leave 4 placeholders for colors. In R, you can name a color and just use the name. Since our last 2 options are the infeasible options, I find giving them a color quite easy. To me, when I can't access something on my computer, it's grayed out. For the first 2 categories, I really want to take control of my colors. I don't want to just supply a name, but do better than that. Going to the colorhex.com website. For my real strong winner, I like shades of purple. Purple's a nice strong color, stands out on a screen. So for alternative C, our best option, I'm going to pick a nice, deep, bright purple. The hex code for that color is available here. And for the other options that are feasible but not our favorites, I'll pick a lighter tint color and use that hex code for those less attractive options. Now that we have a data frame that maps category values to colors, we need to transform this data frame. The dframe function takes a 2-column data frame, puts it in the format we need, namely a named vector in R. We will call this named vector named color vector and use it in combination with the ggplot function scale, fill, manual. Anytime you're disappointed with how data is mapped to an aesthetic, you're going to use some type of scale function from the ggplot package. Zooming in on our colors, I am ecstatic with the results. Alternative C is prominently displayed in a proud purple. A, B, and E are visible as feasible options in the light pink, and infeasibility given as grayed out bars. So we can still see that D has more profit potential than C, but it's infeasible. Now, through a series of functions that you could find on the ggplot cheat sheet, I first get rid of the gray background using a minimal theme and enlarge the font of our axes text. Now, my Y scale, I want to indicate that it is in dollars, so I can use the scale Y continuous. Scale means I'm unhappy with how data got mapped to a visual property. The Y-axis in particular is a problem, and continuous means it is the mapping of continuous data to some sort of visual property that's a problem. In this case, I simply want to create a dollar format for the Y-axis labels. I find the legend for a category unnecessary, or at least it takes up too much room, so we'll get rid of that. And we'll also get rid of the vertical lines behind each bar as they are distracting. The theme function helps us do this, and we pass arguments where the left-hand side is some plot element and the right-hand side is something you want to do with it. These require Googling to get right. I find them hard to remember. Now we'll use the labs function to add titles to our plot and to our axes. Now title really should be your purpose. Make it your purpose, make it explicit, make it opinionated. Don't just say plot of value versus alternative. Say, hey buddy, look at alternative C. It's the best one. And then we don't want our axes labels to be data frame column names. We could take control of those as well. Now this plot is looking nice. Almost there. The last thing I'm going to show you is how to add some text annotation to the plot. We could use the geom text function when we have some data in our data frame that we want to map to visual elements on the screen. In this case, I can take the labels of our category values and put them on the screen. In a similar fashion, if I want to add some text to the screen at a particular location, say on the x-axis above the C alternative and on the y-axis at $25 in value, I'll add these 3 asterisks to indicate this one is really the best option, I think, right now. Woohoo! You've done it. You've made it through the 4 stages of visualization: purpose, content, structure,